How to design culverts. So this is the thing. So just think we have a just design is 10 cubic meters per second, and maximum flow will be the higher to your design. So I think we can provide just 15. And this is it's asking the tailwater data. Tailwater is the data of channel. So what channel will be passed through your culvert. So just think that we have 30 meters width, and channel slope is 0.006. We can reduce it to just 5%. Okay, then we provided the meaning minus 0.0, and inward table is provided just 100 meter. Okay, and you can see this is the channel elevation. You can plot it, so look like this. Okay, then you need to provide the roadway data. What's the road is passing on from your culvert. So this thing is your station 0 meters, and crest length is 30 meter. Okay, it's the crest length is the same as the water width of the road, because the road is passing. Okay, just like your road, this is road is passing like this, and your culvert is this passing. So this is the channel width. Okay, and this is the crest length of the elevation, and this will be the crest elevation will be the higher elevation level. So around 3 meter, we are just thinking that 3 meters is higher, and top width of the road just 3 meter. Okay, then we are just providing the circular. Okay, so just providing the 3000 mm. Okay, embedment, there is no embedment we are doing in the culvert. So now is the side data is the culvert data. Okay, now we will provide the culvert data. This is the elevation. Elevation will be like what level we are providing. Side that is the inlet elevation. So we need to, as we are thinking that the length of the this is the board top width, but with length is will be the this is top width. So top width is 10 meter. So we will apply this one. So we will come with 0.5. So that will be the 100 and 0.5 meters above, and this is the 10 meters length. So that will be the 100 meter. Slope is 0.05 meter. Now we will analyze it. So you will see that there's no overtopping. Okay, so we are already passing the resolution. That is good. Okay, we can see this, and this is that value should be headwater by and eye of the culverts. That should be maintained 1.2 to minimize your culvert size. So we can reduce. I can provide to 1000. Then analyze it. So we will see that is overtopping issue is coming at your maximum discharge. So we need to increase the size. Then go back to your data. Provide 2500. Then analyze again and see this still this thing is there. So then we need to reduce it. 28. Then analyze it again. So there is just little bit is swapping, but we can neglect it this amount, and the ratio is very less. This is the completely about 0.9. So that's okay. Okay, so now I will see the culvert performance. Then this is the inlet and outlet. Okay, so that is good, and you can see the profile and tips thing. Okay, now we will see the energy dissipation. we come back to if there's external dissipator, SAF or Riprap, we are going to design it. So there's the Riprap. You need to, if you want to find out the energy Riprap basin, so you need to select steam bed level structure. Then there is a Riprap basin. Okay, so you can see over here. Yeah, so there, if there's a 0.43, we will provide 0.43 meters Riprap size. So we are just providing 0.4 and 0.5. So you can see here the prep is okay, HS divided d50 is okay, and this is the value. Check d50 by IE depth of the flow, so that is okay. And you can see there's the basin length of your Riprap basin is there 14.316 meters would be there, and basin width 12.344 meter. There's apron length 4.72 meters, and pool length is 9.54 meters. Pool depth is okay. This is the tailwater by depth ratio is 0.217 meter, so that's okay. Okay, velocity is coming this one, and that's the next one. Okay, now you want to see that value for SAF. SAF is then when we provide rectangular ones. So that's the thing, values come. Okay, Riprap level, so that will not count. Okay, if we are provided just 3, and will comes look like this. Okay, if there is a rectangular section, so you can see that number of civil blocks will be 6 there, and their size will be this: height 0.375 meters, civil blocks 0.295 meters, and civil block spacing 0.295 meter. Okay, thank you so much. You can also find out the energy internal distributors such as increased resistance. So you can see over here reference elements you can provide reference section, this one, and the height element height ratio you can provide it, this and this value. So diameter ring, that will be 2.8 meters, diameter opening 2.5 meters, numbers of rows 5 will be there. So you can reduce the sizes and provide the roughness inside the height of the height is okay. That is the result is showing to you. Okay, the exit depth will be 1.9 and exit width to 4.69. Okay, I think you can so do your tumbling flow analysis also. Okay, if you want to find out the energy dissipator, you need to follow the HEC 40. HEC 14 is usually used to the energy dissipator. Okay. Thank you so much. And if you want to see that yes, okay, this is the caption. This is the side section, side view. You can see this is the headwater. You can provide these lease ends on the right. Okay, this is the red one is critical depth, and that is green one also is the normal, and that is reverse triangle. It is the profile, and this is the tailwater, that is cross one, that is cross this one tailwater, and plus with the headwater. This one is headwater. Okay, and but your road is passing through, so we need to increase the road width. So then go back to you, because already we are providing 2.8 meter, and we are just taking this. So we need to provide this for analyze again. So you will see that your road is above. Now road, this is the road, your road level, and this is the your culvert. Okay, and this is the your channel bed. Okay, it's same as you can see it, and there's this is the side view, and you can see this is open view section. This is the 15. Okay, yeah, you can see over here. This is the your road, this is the your, okay, this is the your diameter, this is the pattern. You can see it. Now we design headwater and culvert. It's the culvert. Okay, Thank you so much. Thank you so much.